Welcome back, children. Welcome to Refresh Concepts with me, Dinesh Modi. Now we are heading towards construction of tangents. Now, children, what I'm going to do is that within, from our side in our app, we are not going to solve each and every sum of construction of tangents. For that matter, any construction. What I'm going to make you understand is total different way of understanding construction. So, as of now, we are dealing with construction of tangents, right? I shall make you understand tangents in types, type 1, type 2, type 3, and so on and so forth. So all the construction what we do, we are going to study via types. It sounds something new, right? But I can say for sure that when I teach you and when you pay attention to my entire video, you are done with all the type of construction of tangents. You are done with all the sums, mind you. I can say without solving a single sum, I am done with all the sums which are related to construction of tangents. That's what my aim is. And that's what I'm going to make you understand via this particular video. Right? So let's understand this is all about construction of tangents. Now, children, when I say construction of tangents, in my side, from my purview, I can say that, as I stated, that I'm going to make you understand via types. I can say that there are mainly two types. To draw tangent on the to draw a tangent at a point on the circumference of circle. To draw tangent at a point on the circumference of a circle. Now, in my purview, this is nothing but type 1. So let me say and make use of different markers so that you can understand. This is nothing but my type 1 sum. This is nothing but my type 1 sum. What is type 2 sum then? What is type 2 sum then? I'm going to say type 2 here. Here is what my type 2 is. And we start writing type 2. To draw tangent at a point on the circumference of circle. Now this is nothing but my type 2. I know what you all are thinking. I know very well what you people are thinking. Sir, there is no difference whatsoever in your type 1 and type 2. I really know that. And the last one is type 3. To draw tangent from an external point. To draw tangent, or even you can say tangents, from an external point. Right? This is nothing but my type 3. This is nothing but my type 3. So let me say this is type 3. This is my type 1. This is my type 1. This is my type 2. And that's my type 3. So let me just, draw boundaries so that you can easily distinguish. Right, children? Let's start. Now, when I say type 1 sum, it says to draw tangent at any point on the circumference of a circle. Here also type 2, to draw tangent at any point on the circumference of a circle. Then what lies the difference? Let me make you understand. Here they will say using center. I'm highlighting via different marker. Here they shall say without using center. Once again, Now the picture is clear. Now there are people who will say, okay, now we got the difference. Still, the picture is going to be more clear, children. The picture is going to be more clear. Let's see. We will take the type 3, but at a later stage, let's understand type 1, type 2, which resemble more or less the same, but they aren't the same. So let's understand that by what manner, by what perspective they are different, and how the questions are going to be. So I'm going to plot a general question. We are going to solve it, right? We are going to solve by taking our own question. And believe me, whatever questions I give you as a general question, more or less on the same lines, you'll be having your question in your textbook also, in your boards also, right? Let's start. Once again, to draw tangent at a point on the circumference of a circle using center, to draw tangent at any point on the circumference of a circle without using center. So very first thing is, the point of difference between them is, this one says using center, this one says without using center. There is one more criteria to identify that within a sum, if some words are there, within a sum, if some words are there, then by default it goes to type 2. Even if they don't mention without using center, still it goes to type 2. I shall come to that. I shall come to that. Kindly pay attention. First, we start off with this particular question. So now what is this particular question trying to say? We are taking a general question, mind you. We are taking a general question. So what is the general question? My general question is, question. Draw a circle with center O. Draw a circle with center O and radius 2.8 centimeter. Draw a circle with center O, radius 2.8 centimeter. Point P is any point on the circumference. Draw tangent at point P. Draw tangent at point P. This is what my general sum is. So what is going to be there in your textbook, your syllabus? Some different radius will be there. Point P, again, type 1. If you were to draw tangent at a particular point lying on the circumference of the circle, type 1. They might not say the word using center. They might not say the word using center. If the two words using center is not there, by default it is type 1, mind you. By default it is type 1. If they were to ask you type 2, if the syllabus wants you to, if the board wants you to go and do type 2, they have to mention without using center. Or as I stated, there is one more thing to differentiate. If that thing is there or this thing is there, then and then only go for type 2. Otherwise, by default, if you want to go for tangent on the circumference of the circle, it has to be type 1. It has to be type 1 by default. Whether they say using center or they don't say using center. Are we good to go? Let's start. So how we go for it? How we go for it is that we draw a circle. Children, one more thing. I don't have any instruments. So whatever I'll be doing is a rough one. Right? You need to take it, you need to do it with the help of all the instruments. You have to measure it accurately and perform the same sum. I'm not doing with the help of any kind of instruments. We are doing freehand, right? Draw a circle with center O and radius 2.8. So very first thing is what I'm going to do is, I'm going to draw a circle. I'm going to draw a circle with radius 2.8. I'm going to draw a circle with radius 2.8. Any problem? Now, point P is any point on the circumference of the circle. Children, you are supposed to take point P anywhere you want. You can take point P anywhere you want, right? I shall be taking point P straight. So this is the center of the circle O. This is the center of the circle O. Point P, I shall take it here. Mind you, I can take it anywhere. Point P is here. Extend this line. Straight line. Sir, how much should I extend? It should be more than the radius. That means, sir, should I measure it? No. Your eye vision should say that, okay, fine, this is more than the radius. That's it. I reiterate. Point P is on the circumference of the circle. O to P, a straight line, go beyond. How much? It should be more than the radius of the circle. You need not measure it. Your eye vision should say, okay, it's more. This is nothing but my 2.8 centimeter. So this is 2.8 centimeter. Any problem, children? Are we good to go? Next. Now what? What is next? I intend to draw tangent at point P. So what is the next step? With P as a center, more than half of, mind you, more than half of OP. With P as a center, more than half of OP, arc out here, cut more than half. So arc out here, cut, and an arc out here, cut. So when I say this, mind you, this is 2.8, more than half, cut, rotate it, more than half, cut. Any problem? I'll reiterate what we have done. A circle with center O, point P anywhere on the circumference of the circle, join O to P, go beyond, see to it that it is more than the radius. P as a center, more than half of OP, cut, flip, cut. Now, do we have these 2 points? Mind you, I'm making it a bit larger. You are not supposed to. It's only to make you understand I'm making these points larger one so that you can see and understand. Now, do I have these points of intersection of arc and a line? Indeed. Now, with this as a center, and any suitable radius, draw an arc out here. Keeping radius unaltered, unchanged. You are not supposed to change it. With this as a point, cut. Once again, here, any suitable radius, cut. Same radius, cut. Whatever I did over here, the same things I need to follow down also. Cut. Same thing, cut. I repeat, P is the center, any suitable radius. Now, if you are thinking that should we keep the same radius? No. You can increase, decrease the radius, whatever you want, you can do so. Preferable, increase the radius. Preferable, increase the radius. Cut, down, cut, down. Now, do we have these 3 points? 1, 2, and 3. With the help of scale, first of all, I don't have any scale, children. So, my line may be crooked, my line may be inclined, but your it should not be. First, with the help of scale, check whether all the 3 points are collinear. If so, then and then only go for a straight line which will pass through all the 3 points. Which will pass through all the 3 points. This point, this line is nothing but, tangent. This line is nothing but tangent. Immediately, I'm supposed to mark down this as 90. Very much needed. Radius is perpendicular to tangent. So this is 90. This is 2.8. If you want, you can write down once again. I'm sorry, over here I have written earlier. This is 2.8 centimeter. Right? And we just name it. This as A, this as B, and line AB is my required tangent. Line AB is my required tangent at point P. At point P. My sum is done. A very quick revision. P is the center. First of all, circle with center O. Point P, anywhere, straight line, more than the radius. P is the center, more than half, cut, cut. Next, here, increase, cut, same thing. All the 3 points should be collinear. 90 degree, very much needed. Radius is perpendicular to tangent. This is type 1. This is type 1. How about type 2? So let me give you, I'm leaving one line for a simple word. Actually, in fact, 2 words. So either this will be there or this will be there. If not, then what should be our question? So let's see what is our question. Our question is, my general question is, again, draw a circle. I'm writing a bit short in a shortcut way. We have less space. Draw a circle with center O, and radius again equal to radius 2.8 centimeter. Point P is any point on the circumference is any point on the circumference, draw tangent at point P. Question is the same, but if they were to ask you this question, they will say without using center. What shall they say? Without using center. Now what I'm going to do is, I'm going to make you understand what exactly the steps are. The steps are, we draw a circle of radius 2.8. We draw a circle of radius 2. This is the center, mind you. I am not writing anywhere radius. Now, anywhere you are supposed to take point P. I am taking point P here. Where am I taking point P? Here. This time, slightly inclined, lower side. Any problem? Because point P is anywhere on the circumference of the circle. Right? Now, what are the steps? Keep this in mind. What are the steps? Keep this in mind, please, children. What are the steps? What are the steps is, you need to draw a chord, any chord, right, of any length, not mentioned. So you need to draw any chord, right, of any length, and see to it that it intersects the circle. So say for example, I am taking PQ chord of length 5 centimeter. I am taking chord PQ of length 5 centimeter. P, 5 centimeter in my compass, cut. P, 5 centimeter in my compass, cut. So this is my point. This is my first point. Now you will say that, sir, nobody told you that PQ is off. You rightly said so, but that's what the steps are. Whenever you want to go without using center, that's what the steps are. PQ, 5 centimeter, right? Nobody said. And now I'm going to give you this one. Without using center, either they will use this, or you know what they are going to say? They are going to say one word, or in fact 2 words in their sum. Chord, they have said point P, chord PQ is 5 centimeter. So if they say chord PQ, if you see a word chord, immediately you have to say it is type 2 sum. If you see a word chord, immediately you are going to say it's a type 2 sum. If this is not there, then they will give you without using center. And if this is not given, they will give you chord. Either of the thing has to be there for the sum to be type 2 sum. Are you getting me? So here in my question, I have used the word using the center. So what they might say a question, draw a circle with center O, radius 2.8, point P is any point on the circumference of the circle, chord PQ is 5 centimeter, draw tangent at point P. Then they will not use this. So either they will mention a chord length or they will mention this. If they mention a chord length, we have to take that chord length. But sir, if they don't mention chord length, then call is totally yours. If they don't mention chord length, the call is totally yours. It is you who are supposed to take any chord, 5, 5.2, 4.5, whatever you desire, whatever you prefer, you are supposed to. When the chord length is not mentioned. Why? Because chord length or having a chord is part and parcel of type 2. Are you getting me, children? Right? So what we have done, a circle with center O, P is any point. Since over here chord length is not given, we have taken any random chord, Q, any random chord. Any problem? What next? Now you need to take a point on the other side of the chord, an extra point. You are supposed to take that particular point anywhere, mind you. You are supposed to take that point anywhere. You could have taken this point M here, wherever. But I have taken it slightly upwards so that you can easily see. Right, children? Now what? We join M to Q, we join M to P. Once again, what we have done, a circle with center O, radius 2.8, any point P, any chord length since not mentioned. If mentioned, then that chord length only. cut. Then any extra point on the other side of the chord, M, join. Now what? Now pay attention. Students find this step very difficult. It's very easy. We are going to draw angle congruent to a given angle step. So M as a center, M as a center with any specific radius, any suitable radius, draw an arc. With M as a center, any suitable radius, draw an arc. So this is what my arc is. I repeat, with M as a center, any suitable radius, draw an arc. Keeping the same radius, do not change the radius. P as a center and see to it, it cuts the chord in a circle. Mind you, cutting chord is must. So P as a center, cutting the chord and then going beyond. Any problem? Right? Now, can you see these 2 points? I'm making it dark as I said. I'm enlarging it. You people are not supposed to. With any one point as a reference point, from here to here, measure it. From here to here, or you can measure from here to here. Choice is yours. Measure it. And then from this point of intersection, mind you, from here to here, this is a point of intersection, cut. Wherever it is getting cut to the arc. Once again, M as a center, any suitable radius, an arc. Same radius, P as a center and an arc. See to it that it cuts the chord. Then from here to here, point of intersection of the arc and the chord, cut. Now can we see this well-defined 2 points? That's where I am going to join a line. And now I'm going to make a radius. And immediately going to say that this is what is 90. Radius is perpendicular to, and this is 2.8. Radius is perpendicular to tangent. Give one more point, say S. Line PS is the required tangent. Line PS is the required tangent. Now let's change the question bit slightly. Draw a circle with center O, radius 2.8. Point P is any point on the circumference of the circle. Right? Stop. Draw tangent at P, no. Then they will say chord. So let me write down other question. From here with a blue marker, it's other question. Chord PQ is 5 centimeter. Draw tangents at P and Q. So method is going to be the same. Circle, point P anywhere. This time not any chord length, exactly 5, wherever it is getting intersected on the circle. But you have to intersect it on the circle. Huh? So point Q. This is 5 centimeter, I have to name it. Then whatever I did for P, point P, whatever process we adopted for point P, simultaneously that should be adopted for Q. So if I were to say, what did we do thereafter? Point M, then a suitable arc with P, same thing. Whatever I did with P, the same thing should be done with Q also. So simultaneously, work out simultaneously. Sir, this is going to be for Q. This was for P, simultaneously, this is for Q. Again, measure here to here, then from here to here, cut. From here to here. Now, both of them, this will be the another tangent, 90 degree. And the examiner can always ask you that hence measure the length of tangent segments from the external point. Mind you, whatever shall be PS shall be QS. Reason, length of tangent segments drawn from the external point are congruent. Whatever you measure PS has to be QS. Why? Length of tangent segments drawn from the external point are congruent. So if, say for example, since I have drawn a rough sketch, so I don't know exactly what is the answer going to be. So say for example, this is 4.8. Say this has to be 4.8, and you will write down length PS is equals to length QS, which is equals to 4.8 centimeter. Whatever, I'm just giving you a fake number, any arbitrary number, but that's what it is. Maybe at times even the examiner can also ask you the distance of point of intersection of both the tangents from the center. Measure it and write it out. Many boards ask this also, that hence write down the distance from the center of the circle to the point of intersection. Measure it and write it out. They may ask you the length of the tangent segments. One thing should be kept in mind, both the tangent segments will be congruent, equal. I hope my children have got it. Type 2. Right? So now are you in a position to distinguish? When I started my video, people were thinking that, oh, these are the same. Then what's difference in that? This is what the difference is. You can check it out. Right? Now comes type 3. Now comes type 3. Type 3 is quite interesting. To draw a tangent from an external point. So type 1, type 2, it was on the circumference of the circle. This totally differentiates itself from type 1, type 2. Totally differentiates itself. Why? Because this is not there on the circumference of the circle. This point is somewhere outside. This is somewhere outside. So let me directly give you a question. Right? And what should be there in the question for you to claim this as type 3. For you to claim this as type 3. So let me write down the general question. Question will be, let me write down the general question. The question will be, draw a circle with center O and radius 2.8 centimeter. I'm keeping the radius same. Point P is at a distance of 7 centimeter from point O. Point P is at a distance of 7 centimeter from point O. Either they will write down this much as a statement, or they will use, instead of this entire line, they may use distance OP is 7 centimeter, meaning is the same. At times they will give in wordings, at times they will give in this way. But the moment you see the word distance, just tell yourself this is type 3. Distance OP is 7 centimeter. Draw tangents from point P. Draw tangents. I'm sorry, it's a bit messy, I can understand. Draw tangents from point P. So how to go for it? Let's understand, children. Let's understand. A circle with center O, radius 2.8. So the process is the same. We go for a circle. Construction of a circle with radius 2.8. Right? Now this is the center of the circle O. How far is point P? Point P is at a distance of 7. So this is O, this is P. How much this is? This is 7 centimeter. Mind you, this is 7 centimeter. Any problem? What we did? So I'll just repeat. It's circle with center O. Point P is at a distance of 7 centimeters. So from O, we measured 7 centimeter. Any problem? Now what? With O as a center, more than half of OP, draw an arc. In short, we are going for bisector of OP. What are we going for? Bisector of OP. O as a center, more than half of OP, arc here, keeping radius unchanged, unaltered. P, cut. O as a center, more than half of OP, need not measure it. Cut down, P, cut down. Join this. Is this bisector? Immediately I need to show this. Moreover, it's a perpendicular bisector. Moreover, it's a perpendicular bisector. Any problem? Circle with center O, point P is at a distance of 7 centimeter. Thereafter, O as a center, more than half of OP, cut, cut. We went for it. It's a perpendicular bisector. We need to show all these signs. Right, children? Now, let me say this is point M. Let me say this is point M. With M as a center, either MO as a radius or MP as a radius. Either MO as a radius or MP as a radius. Choice is yours. Most preferred is MO. Right? Draw an arc. Draw an arc which is cutting your original circle here and then here. Normally you need to go for an arc. There are many boards who will say that go for a continuous arc. Go for a continuous arc. Choice is yours. Choice is yours. Go for a continuous arc. I repeat, M as a center, MO as a radius, go for an arc. Did you see very well defined points made by this arc on the circle? Right? Let me say this is A. Let me say this is A and this is B. Now with your scale, point P and A, with your scale, see to it, join. B to point P. If you want to extend it, you can stop at P also. Immediately, radius is perpendicular to tangent. So, 90 degree, radius is 2.8. We need to write down in inclined way. Immediately, 90 degree and 2.8. Any problem? Once again, a circle with 2.8. Point P is at a distance of, right? Now, O as a center, more than half of OP, arc, cut, cut. We went for perpendicular bisector of OP. Let the point of intersection be M. So we show these signs, 90 degree. Now, M as a center, MO as a radius, go for an arc. We have a very well defined point A and B. Join PA, PB. There are very few boards who demand for entire circle. So let me show you a different marker. Who demand for entire circle. In that case, again you will get a well-defined circle, so long as you are correct. So long as you are correct. M as a center, MO as a radius, you need to go for a circle so that you know somewhat it should pass through point P. It should pass through point P. I have drawn very roughly, children, but it should pass through. So there are very few boards who will ask you to go for a circle, but there are certain boards. There are certain boards who will say that, okay, fine, drawing only this arc is suffice. Drawing this arc is suffice, more than enough. Are you getting me? Last thing, what is the last thing? They will once again this particular question, they will ask you, find the length of tangent segments. So whatever is PA shall be PB. So if you measure PA, you will get answer, say for example 6.4. So length PA has to be equal to length PB. You cannot have two different length segment. Length PA is equal to length PB. I'm just giving you a rough number, 6.4 centimeter. And finally, line PA and line PB are required tangents. From point P. From point P. Children, this is what type 1, type 2, type 3 is all about. This is what type 1, type 2, type 3 is all about. What is type 1? Drawing tangent at any point on the circumference using center. If nothing mentioned, by default type 1. So, very quick revision, circle, radius, extended. Any point P, more than half, cut, cut. Here, cut, cut. If they want this, they will use without using center. If not, chord length will be mentioned. If chord length is not mentioned, it is our duty to take any chord because chord is part and parcel of this type 2. Circle, any point P, If not mentioned, any chord length. If mentioned, specific chord length. Go for it. Any point M, join. M as a center, cut. With P, cut. See to it that it cuts the chord. Measure here to here, measure here to here, cut, join. If they say to do at P and Q both, same process has to be adopted. Questions can be asked are, what is the length of tangent segments? We are aware, length of tangent segments drawn from the external point are congruent. It should be equal. Last, from any external point, so there will be distance being given to you, 7 centimeter. Right, here in our sum it is 7 centimeter. We went for a circle, OP. Then we go for a bisector of OP. M as a center, MO as a radius. We go for an arc or entire circle depending upon the board. Very well defined points, join. Now before we come to an end, let me tell you now. There are many who will find when you work out type 3 sums. When you work out type 3 sums, there will be 3 cases arising. In one case, your perpendicular bisector will be far away from the circle. In some other cases, you will feel the perpendicular bisector is coming exactly tangential to the circle. It is exactly becoming tangential to the circle. That doesn't mean it is type 1 sum. No. In some case, this perpendicular bisector is going inside the circle. At that point in time, you might think that what Modi sir said was, oh, in his figure, the perpendicular bisector was outside. Now, for me, in some sums, it is coming exactly tangential. For some sums, it is coming inside. Now, there is something wrong. No, children. It depends upon the distance. It depends upon the distance. Let me make that picture also clear. If the distance is more than, understand this, if the distance is more than double the radius, the perpendicular bisector will be outside. Listen to me first and then I'll make you understand. If the distance of that particular point from the center is more than double the radius, the perpendicular bisector will be outside. If it is equal to double the radius, the perpendicular bisector shall touch as a tangent. And if it is less than double the radius, it is going to be inside. I shall prove it. What is radius? 2.8. Double of that, 5.6. So, my perpendicular bisector has to be far away from the circle. Had this been exactly 5.6, point P is at a distance of 5.6, believe me, you can draw it out. You will get this perpendicular bisector exactly tangential to the circle. And say for example, point P would have been at a distance of 5 centimeter, you would have got your perpendicular bisector inside the circle. So the position of perpendicular bisector will change depending upon the distance of external point from the center. Right, children? This is what the construction of tangents are.